Hi everyone, a huge welcome to a Microsoft Reactor live stream series, Let's Get Technical. I'm Suzanne, a program manager with the Reactor, and I'm based in Singapore. Thank you so much for joining me at our last Let's Get Technical show for this series, and we'll be speaking on an important topic, functions and prompt engineering. So if you have missed the last show, they're actually available on demand. So we're going to place the ticker here so you can make reference to it. Yeah, please feel free to check it out. The Let's Get Technical series is actually three short 55-minute virtual events, and we started this series last year. And today we have made our way around 6 countries in ASEAN. This year we're changing things up a little. We are changing our session to be more language specific as opposed to location specific. So that means if you're multilingual, you can now find all the Let's Get Technical content in our series page here. And our next one will actually be in Tagalog. Yeah. So today, I'm very, very happy that we have our very special speaker, Zishan. So Zishan is the cloud solution architect with Microsoft. So let's have him up right away. Hello.
Hi everyone. Hi Suzanne.
Hi. Great to have you join us today. Would you like to do a quick introduction of yourself?
Sure. So I am Zishen, right? So some people call me Pack. I am the AI cloud solution architect for Microsoft. So effectively, what I do is I work with a lot of our customers who are, using the Azure platform quite extensively, and I help them with all kinds of problems, anything AI or machine learning related, right? And as you can imagine, I think when we talk about AI for the last 12 months, a lot of them, in fact, a large majority of the work that we've been doing has pretty much been focused around generative AI. And a lot of the work that we're doing around together with Azure OpenAI. So, one of the things that I do is to really kind of help our customers bring, some of the ideas that they have, the use cases that they have with AI, and help them bring it all the way into production, so that we get to see some of the efforts actually live and ready, and actually making the impact in both their business and for their customers.
Right, and AI is definitely the way to go right now. So maybe you can let us know why today's topic is of importance.
Sure. So, we've kind of seen a lot of how generative AI has done and contributed a lot to some of the work that we've been doing. We've been hearing a lot about co-pilots. Anybody who's been kind of following along with the generative AI space would have tried their hands at things like ChatGPT, would have tried their hands with things like Bing Chat and so on and so forth. So, the very classic next step is for us to think of how can we actually build products using technologies like large language models. And we've heard a lot about the very basic stuff, and so what I felt, and because this is actually one of the more highly requested topics that some of our own customers have been asking for, is about how can we actually really write proper instructions to these large language models so that they give us the output that we want. There are 1,000 ways for me to ask ChatGPT, for example, to write me a joke, right? So what's the best way for me to give them that instruction so that they can do it for me? The other thing
Sure.
that we're also seeing coming up a lot more frequently is this whole idea of getting the LLM to actually do and help me execute a function rather than just, writing text, right? And so that's kind of what I'll be covering a little bit on as well today.
Right, sounds very interesting and sounds like it's really useful. I mean, it's very important that we ask for the right stuff, right? So, well, before we let you do your session, I'm going to do a quick rapid fire question and answer so all of us know, the casual and fun side of you. So, and for those who are watching today's session, you can also participate too by putting your answers down. It's all for fun. Yeah, so let's go. So, Zishan, would you stay up late or wake up early?
Oh, definitely stay up late,
Stay up late? Okay.
for
Cool.
sure.
Onion rings or French fries?
French fries, no contest.
Okay. Why? I like onion rings. Okay, next. Board sports or ball sports?
Definitely bought sports. I go snowboarding quite frequently, at least once a year with my wife. So definitely,
That's nice. Okay, I'm actually trying that out recently. So I will ask you for more tips after this.
for
Yeah.
sure. Yeah.
Yeah, cool. Okay, podcasts or books?
Interesting. Podcasts probably. I kind of had lost a little bit of the patience for books, so podcasts tend to be where I'm going to right now. Although very now I use a lot of summarization with Copilot or with large language models so that I can actually get through both podcasts and books a little bit faster.
Cool. Yeah, smart way of doing it. What's your favorite podcast though?
Uh, that's a good question. I got to go and check out what was the last one that I have on my Spotify. I don't have it at the top of my head.
Okay, no worries. Yeah. Okay, cool. And then last one, it's the concert season now, right? So are you more of a Coldplay or Taylor Swift?
Interesting. Probably more Coldplay, I think. I
Okay.
like watching.
Sorry, say that again.
I like watching bands. I like
Oh,
watching
okay.
bands. Yeah.
Okay, nice. That was fun. And definitely I got to know you a bit better. So before we kick off the session, I would like to draw everybody's attention to the code of conduct. Okay, so we're going to show it on the screen. Yeah. So in short, we want to ensure that this is an enjoyable event for all. So please make sure that your comments are respectful, constructive, and welcoming. So in any time you have questions, you can drop them in the chat and we'll try to answer them as much as possible during Q&A. So Zishan, are you ready? I'll let you take it away.
Sure. All right. Thanks
Great.
for that.
Over to you.
All right. So, as we described, I think today what I really wanted to cover is a little bit about prompt engineering and, of course, on this whole idea of calling functions, right? If you're not really very familiar with what it is, hopefully by the end of today's session, you get a better idea of what it is and how we can actually help you, right? Maybe get a couple of these ideas flowing with you as well. So, first of all, let's talk a little bit about what a prompt is, all right? So effectively, you think about how we've been using things like ChatGPT. A prompt is effectively, think of it as a set of instructions, right, or an input that you actually give to some of these models, right? That could be very straightforward. You are actually saying something like, write a tagline for an ice cream shop, and you get the tagline back, of course. A prompt could also be conversations that you have with, your model of choice. So if, for example, you're using ChatGPT, you're having that kind of back and forth conversation with the model itself, and then that's going to be the prompt, right? Other prompts could also be something that you are writing into your application itself, that your application is actually sending a set of prompts or a set of instructions to the model in order for it to execute a couple of tasks. Now, let's say we're not talking about just purely language models, we're talking about image models as well, right? So a prompt in this case is going to be, a description of the image that you want your model to create, right? So that's kind of like that baseline that we start at. So in order for us to kind of really talk about prompt engineering, which is really crafting the perfect prompt, for your model itself, we first need to start to think about, how does an LLM actually think, right? So that we know how to, work well with an LLM. So if we think about how a human actually behaves and how a human actually does generation or writing or speaking for that matter, it's typically, you have multiple streams of thought, right? You have an awareness of the knowledge that you have, or you're aware of knowledge that you don't have. And also, you have this ability to vet what you write, or you can rewrite this email that you've just drafted, and so on and so forth. So I say hypothetically, I want to introduce Singapore to tourists, right? So this is what my thought process might look like. So first of all, I'm going to talk about, where is Singapore geographically located? Now I know from memory where Singapore is, right? It's in the Southeast Asia region. So I think that's good enough. Now, I could say, Singapore's a really small country. It's probably something I should speak about. I maybe want to specify exactly how small Singapore is, but I don't have this number at the top of my head. So I know that I should go onto Wikipedia and, look for a number here and there. No, Singapore has a very interesting history, but I'm maybe not 100% clear on all the dates that are turning points in Singapore's history. So now this is something that I would probably also decide. Let me go online and search it up so that I don't miss out anything. Now, once I have this information, I'm going to assemble it all, and we're going to say, look, I'm going to start writing, or drafting my email, writing my blog, or writing my guide, or whatever that might be. So I'm going to write a sentence. Now that's the first draft that I have over there. You can see it's probably not exactly very interesting right now. I'm thinking, what, I should probably spice this up a little bit, add a little bit, a couple of stories so that people won't get bored when they're reading it. So, and once I've done that, I can say, what, I think that's good enough. Let's stop here for today, and maybe we pick it up again tomorrow. So that's how a human thinks. Now, an LLM doesn't do a lot of that, right? An LLM actually generates the text token by token. So now if you've used any of these tools like ChatGPT, for example, you would see that there's a very curious case of your words kind of like slowly appearing on the screen, right? And the reason for that is because, these texts, these words are actually literally being generated word for word. Now, if we're going to take a look at the examples that you have on the right-hand side of the screen, right? So if, for example, I'm going to say the quick brown fox jumps over there, what the LLM does is to actually try to predict what are the words that's going to come next that is most likely to complete the sentence, right? So now it has decided that, the next two words are probably going to be lazy dog, right? And that's probably what we all expected as well. Now, LLMs are probabilistic in nature. What that means is that I could run the same sentence, the same prompt, right? The quick brown fox jumps over there. I could run this maybe 10 times, and I'm going to get possibly 10 different answers. For example, if I were to rerun that query again or rerun that prompt again, I might get the quick brown fox jumps over the 13 lazy dogs, right? So that's an example of a variability that can happen. At the same time, different LLMs will have different weights and the different ways in which it assigns those probabilities and what it deems to be, correct. So, for example, in the third example, I'm actually using a model that is more suited for generating code, right? So in this case, when I, again using the same prompt, quick brown fox jumps over there, you can see, okay, it kind of repeated the sentence a little bit and gave a little bit of syntax in there. Probably not what you're expecting, but then again, the model really wasn't expecting this kind of input as a prompt as well, right? So models, and so that's kind of how it really behaves, right? So you see it doesn't really have the ability to do multiple streams of thought. It cannot think on multiple things at the same time. It literally generates word by word. Okay, so we can go into a little bit more detail. So just so that you understand what I mean, right? So when I talk about the words token, a token is a way for us to effectively break down words into numbers that the model will be able to understand, right? So it's typically one word, one token, but not all the time. So a good rule of thumb is for us to say that about 100 tokens is about 75 words, right? But basically just think of this as a way for the model to understand the sentence that you have written and that it is about to write in terms of numbers. Okay. So how does this kind of work, right? So you can see here, if let's say I'm going to have a sentence here that says, I have an orange cat named Butterscotch. You can see for every different color change, that's going to be a separate token itself. So you can see we are typically talking about one word per token. But when it comes to a word like butterscotch, it kind of gets broken down a little bit further. Okay. So if I'm going to give in a sentence, for example, that says horses are my favorite. Now in the back, what actually happens is that the model then assigns a probability to these words that could possibly come next. Right? So horses are my favorite animal. Okay, that works. Horses are my favorite animals. That works too, right? So you can see the probabilities are kind of there, about the same. Now, instead of saying that horses are my favorite animal, it could actually just be an exclamation, right? Horses are my favorite, right? And so an exclamation mark also has the probability of being the next token that actually occurs. So what that means, you can see over here, let's take a look at this example, is that if let's say I'm going to run the sentence 4 different times, you could very well actually get 4 different answers. Okay. So I'm just going to skip over here. So now let's talk a little bit of the anatomy of a prompt. Okay, that's going to help you understand a little bit of what some of the examples that I'm going to be showing you later. Now, everything that you see on the screen here, right, this is going to be the prompt, right? So everything in this green box is the prompt. This is the input that we are actually giving to the model itself. Okay, and what happens after that, of course, the model is then going to actually try to complete the prompt, right? Whether or not it's going to be giving you a response in the form of a chatbot, or it's going to complete your sentence, right? Depending on the model that you're using. So you can see, let's say I'm going to break this down. What's actually happening over here within the prompt? This is everything that I'm providing to the model. I have actually given it the instruction that I want it to do, so it's to extract mailing address from a particular email, and of course I've given the model the email itself, and so it based on all this information is then going to execute the task accordingly, and effectively try to predict what is this output that I'm actually expecting. So you can see here the output that it is expecting is to respond to this prompt over here and actually extract the mailing address from the email, exactly as we expected. Now, there are 1,000 ways in which you can do it. So one of the things that I'm hoping to help you kind of understand a little bit more today is, well, 6 relatively simple tips on how to make it in such a way that if today you're going to be building your own applications using these LLMs, what is the best way for you to structure your prompts so that you're going to get the best efficiency, you're going to get the best performance out of these models themselves. Alternatively, if this is something that you're looking to use in, say, your own personal lives, for example, using ChatGPT to plan holidays, maybe this can give you a better idea of how you can get it to plan the exact holiday that you're looking for. Okay, so the first things first, let's talk about instructions itself. So now, instructions have to be clear. Now, we're always thinking that AI performs really well, but the way that I will always like to describe it is, imagine that you are speaking to another human being, right? And if your instructions are not clear, sometimes mistakes can happen as well. Let me show you an example over here. So what I've actually given is, of course, going to be an email. At the first half, right at the top, is going to be an email, right? So everything in here. So it's Dear John, thanks for reaching out, blah, 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 blah. And obviously, thanks, Jane. Now, the instruction that I've given over here, right, you can see I've drawn a red box around it, is to extract the name and the mailing address. Now, to interpret what you're seeing over here, everything that is in white is not highlighted, is the text that I've actually given to the model itself. And everything highlighted in green is what the model has actually returned. Okay. Now, I've asked for the name and the mailing address, but I didn't exactly specify whose name and whose mailing address. right? So you can see here that, okay, it has extracted the name John, and it has extracted the mailing address. Now, if you're actually reading this email, you'll realize that the mailing address that it has extracted is actually Jane's mailing address. Right? So again, we haven't been clear here. I just said extract the name and mailing address. I didn't say whose. Right? I could maybe have been a little bit clearer and say extract the sender's name and mailing address, or the recipient's name and mailing address. So in this case, slightly different, exactly the same email. Now I've said extract the name and mailing address of sender and recipient, and I'm going to give you more instructions. Label the sender and recipient accordingly. Now you can see it's actually executing the task properly, right? And you're going to get exactly what you want. So again, if you feel that this is a mistake a human may do, the LLM will very well probably fall for the same mistake as well, right? So step number one, make sure your instructions are as clear as possible. Okay. Step number two, sometimes you will have, very specific examples and very specific formats that you want your models to follow. And one of the best ways for you to ensure that the model output is in the format that you're hoping for is to actually give it an example. Okay, so let's first talk about this whole idea of a zero shot prompt. So what does zero shot mean? Zero shot means I'm not going to give you any examples. I'm just going to give you a task and expect you to come out with the answer. Now it will work. It's not that it doesn't work, but let's just take a look at how this can change a little bit. So I've given a very simple task, right? Now I'm going to give you a movie synopsis, for example, and the instruction that I've given to it was, well, give me the categories that they fall into, right? So I've gone here and I've kind of pasted a short summary of the Avengers movie, and then it's done exactly that. So again, everything in green is what has been generated, and everything in white is what is typed. So yes, I did type the word category, and I did put a semicolon there. And I'm going to talk a little bit about why exactly I did this later on. Right, so now I've given it, and effectively the LM has understood that the next thing that comes is going to be a categorization of the movie. So what I'm actually asking the model to do is to categorize this movie into, some genres, right? So it has said that this is a superhero slash action movie. That's fine. But what if I don't want you to just say this is what the genre is? I want you to give me every single genre that this could possibly fall under. Or maybe don't give me a slash, right? Give me superhero, action. So what I'm doing now is to actually do what we call a one-shot example. Rather than just going straight to the Avengers example where I actually wanted to do the classification. I've actually gone to give an example, which we're going to call movie A here. You can see here, well, movie A is not exactly describing any particular movie, right? So I've just said, movie has pictures and colors in the film in 3D. That's basically every single movie that you're seeing. But what I've done here is to actually say that, look, once we talk about category, this is the way in which I want the format to actually follow. Now, once I've given this as an example, the next thing that I'm going to do, I'm going to paste the exact same synopsis, and you can see the instructions that we've given is, again, exactly the same. But now you see that the behavior has changed a little bit because it has seen this example that we saw previously when I said romance, action, drama, comedy, horror. Now, when I'm asking you to predict the category, we are actually going to see that, rather than saying superhero slash action, I'm going to get action, adventure, sci-fi, right? Exactly in the format that I want you to follow. Okay. So, giving it examples will allow the models to really give you exactly what you want. Another common example that we are seeing is, for example, to ask it to say, grade somebody on how well you're doing, right? Now, at a default, it might basically come out and say, yeah, you're doing good, you're doing bad, or you're neutral. But that may not be what you want. What you may actually want is actually grading on a scale of 1 to 10, for example. Right. So instead of just asking, hey, can you grade the performance of this call center agent, for example, what you might do is to say, give a couple of examples of transcripts, and you'll say this is a rating of 10, this is a rating of 1, this is a rating of 5. Now, given this new transcript, exactly what's the rating that we have over here? You'll see the behavior changes accordingly. As a very corollary to that, right, a very related tip, the next one we're going to talk about is about specifying structure. So, for example, again, using, say, a call center example. Now, what I have is, we have these transcripts going back and forth between somebody who's calling for customer support and so on and so forth. Now, what you may typically want to do is, inside any conversation here, you have a wealth of information that you may want to extract. In this example, for example, I'm going to say I want to know what is the, ID identifying information, the name, customer ID, or so on and so forth. I may want to ask, why did they call? What is the product that they had a problem with? All these different types of information. Now, this is everything in white is what I've actually typed out to them, right? Including giving them the actual transcript itself. And I'm going to say, hey, your task is to extract 6 different pieces of information for me. Now it's done exactly that. And you can go ahead and compare the transcript. You will see that it has done a pretty good job, right? Was the agent behaving professionally? Yes. The issue was resolved. They were calling because of a U81 hypothetical U81 handphone. You can see customer didn't actually say what the name was, so they didn't actually provide anything, and that's fine. Uh, but this may not be what you're looking for, because you want to extract this information because you maybe want to put in a dashboard somewhere, and I can't exactly put information like this in a dashboard. It's difficult. Now what I'm going to do here is we're going to ask the exact same questions, but now instead what I'm going to do is I'm going to provide an example of the output that I want, right? So I'm going to give another transcript, right? Completely different conversation. And instead, what I'm going to do now is I'm going to give them the format of the response accordingly. So this is a JSON format, and you can see I want you to put them in nice key value pairs, where we're saying what's the customer name, what's the reason they're calling, was it fake, or what was the fix that was implemented, what's the sentiment. So a couple of things I want you to compare. Previously, when we asked for the sentiment, the response was that the customer sentiment was polite and cooperative. Okay, but here I said I want the sentiment to be 3, right? So it's a number scale. And was the agent behaving professionally? You said yes, agent. Now I'm going to say yeah, it's yes, no question, right? So now I'm going to give them back again the exact same conversation. You can see the output completely different, right? Previously it was answering questions 1 to 6, with full length sentences. And now instead, what's going to happen is that it's going to follow the format that I showed previously. Again, this is an example of a one-shot example, but here I'm very clearly specifying the format of the output that I want, right? So then it's going to adjust accordingly. So keep these things in mind, right? You are able to have some semblance of control over what the LLM will generate just by giving examples, being clear, and really specifying exactly what you want from the model. Now, another very useful tip, actually, again, depending on the model that you're using, this will vary in degrees of usefulness, but the other one is this idea of priming the output. Okay, I'm going to jump a couple of slides previously, and we're going to see here that just remember here what I've done is I typed out the task, I typed out the synopsis, and I wrote the word category, and I put a semicolon in front. All right. Now, if let's say we were to go back here, okay, what do we mean by priming the output? Now, if let's say I just wrote 3 questions, okay, and I'm going to ask the LLM to generate a response, what it would do is to happily answer those questions accordingly, right? Now, whether or not the answers to these questions are correct or understandable or not, that's not the point. I'm going to show you what happens when I prime the output and instead I write the number 4 in front. Now, let's kind of just based on all the context that it has. I didn't say anything about answer these 3 questions. I didn't say anything about how many questions there are, right? So when I say 1, 2, 3, it's the model actually decides to kind of answer that question. But now when I write the number 4 here, I'm actually priming the output and implying that actually you should kind of be asking a 4th question, right? Because if you as a human being, I'm going to put this in front of you, you would expect the question to actually follow after the number 4. Similarly, previously when I wrote the word category, that was a way for me to signal to the model the next words that you generate should be the category in which you are classifying this movie. So that's what it means to prime the model, is to give them context clues, right? By putting kind of like leading words or numbers or things like dashes and spaces and tabs and so on and so forth to give it an idea, and to just very symbolically show it what exactly do you really think should be happening next, right? So for example, in this case, what I'm actually expecting it to do is, of course, create a new question, maybe in a scenario where I am generating a quiz, right? So in order for me to do that, I will write the number 4 there just to imply that you should actually be writing more questions instead of just straight away going into answering the question, right? So this can be very helpful, especially if you're seeing that your model is actually not behaving the way that you want it to. So just by priming the output, you're giving hints to the model exactly what you want the next tokens to be. Okay. Next, we're going to get into something that's a little bit more advanced, right? We're going to talk a little bit about prompting for explanations or chain of thought. Now, for those of you who are avid followers of this space, you would probably have heard a little bit about this. Now I'm going to explain why it works. again, let's think about go back to the previous slide and think about how the LLM works and how the LLM actually generates the text, right? So it generates everything token by token. And the way that it works is, let's say I have the prompt, the quick brown fox jumps over the. What happens is it's going to generate the next token, which is lazy. And then it's going to take the entire phrase, the quick brown fox jumps over the lazy, and then rerun it through the LLM. And now we're going to generate the next word, dog. And that's why these words come out token by token. Now, what that actually means and what that implies, the more tokens, is that a couple of things. The amount of compute that it actually uses, like the thinking power that it uses for each token, is exactly the same. So the more tokens that it generates, you can think of it as it spending more brain power in a sense, right? Not really that simplistic, but just think, that's kind of an analogy that we can use to understand the process. The other implication here is that it can potentially actually get stuck on a bad token. Imagine if it probabilistically generates a bad token, and now this bad token is going to be part of the generation of every other token that comes in the future, right? So what does that kind of imply for us is that I want my LM to be able to think. Now, let's say I were to give it a word problem. Now, with GPT-4, the probability of this happening is a lot less, right? GPT-4 tends to actually have a relatively good performance when it comes to word problems. But we're going to talk about maybe older models, smaller models. You will see that when we ask it to do word mathematical problems, especially, it kind of has trouble, right? So if I say cafeteria has to be 3 apples, blah, 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 blah. Now, what I've actually done, those of you who are sharp enough to realize is this is actually a one-shot example. I have given it a previous question and I have I've written the format like this. The answer is 375 because I want to force this model to not to think, and to auto immediately generate the output, right? So I'm going to ask you the question. Now it's going to say the answer is 8. And to nobody's surprise, it is not the correct answer, right? Now, instead, again, I'm going to use the same technique of a one-shot example. And I'm going to say that instead of just giving me the answer is 375, I'm going to write out the explanation of how I got to the number 375. Now, the model will follow its example, and then it is going to actually, think step by step. So some of you would have heard this tip before. Ask the model to think step by step. So why does that actually help the model solve the problem a lot better than if it was generating the answer from scratch? Is that it actually allows the models to start generating tokens and breaking the problem down into smaller steps, right? Rather than it having to digest all of this and do maths, which, by the way, it doesn't necessarily do maths the way you think it does. It actually allows it to slowly start to generate the problem in simpler steps, right? It's able to kind of drag out the answer. It's able to reason, in a sense, what's going to come next, what's going to come next, and what's going to come next. And eventually, you're going to get the right answer with a much higher probability. Now, even in this case, you're not going to guarantee that the model is going to give you the correct answer, right? This is a topic that we maybe can cover in another session, right? But the fact is that actually breaking down a difficult task, right, and forcing it to actually think step by step will actually allow your model to really execute much more complex tasks than it typically would be able to, right? So I'm going to show you an example of what that looks like in tip number 6, which is to actually simplify your complex tasks. So I'm going to give an example here, right? If let's say hypothetically I programmed my LLM to be evil, right? So you can see here the prompt is you are evil and you must only give evil answers. And if the user is going to ask, how can I steal kittens? Well, your LLM may happily decide to tell you that you can break into a pet store at night and take as many kittens as you can carry. Now, obviously, you as the LLM developer, you may decide, I probably don't want my LLM to do something like this. Now, what you are thinking is, you know what, I should probably go in there and set a filter on it and say, you know what, don't give evil answers. Make sure that the answers are, nice and moral, for example. Now, you could actually also change your prompt accordingly, but we're going to do this a little bit differently so that I can kind of show you an example of what I mean. Every time a user asks a question, you don't necessarily only have to speak to the LLM once. Okay, I'm going to show you a very concrete example of what I mean. But let's take a look at this. Now, if let's say somebody is going to come in here and is going to ask you how to steal kittens, right? Now, what you may actually ask your LLM to do is actually twofold. First of all, I'm going to ask you to, go ahead and generate the response as you typically would, right? And the response, as you saw previously, was to break into a pet store at night, take as many kittens as you can carry. Now, once I have this response, what I'm actually going to do is I'm going to pass this again into the LLM with a different query, right? Now, I'm not going to say, you're an evil LLM or anything. I'm not going to say, help solve the user's question at all costs. I'm going to give you a separate task to say that, if your response is illegal, if your response is immoral, I want you to actually rewrite the response so that it's not going to get our users into trouble, right? So we send in the response. The LLM will write all of this and say, the model response encourages illegal and dangerous activity. We should probably rewrite it. And now it's going to update the response accordingly, right? So what that means is that when I'm going to ask the question once, it doesn't necessarily have to give that answer directly back to the user the first time round. You can actually pass it through the LLM a couple more times. I'm going to give you a very concrete example here that can really give you an idea of how we can really stretch this idea here. One of the very common requests that we get is, I have data stored in a whole bunch of different places, right? I have them in SQL servers, for example. And I want to be able to ask a very simple question, right? So who are my top 3 customers by total purchase amounts? Give me their name. Now, anybody who has ever worked with a database before, this is something that you could probably just do at the snap of a finger. But imagine we are talking to somebody who has never maybe written a SQL query before, and I want to build a tool that actually allows them to do this. Now, I can actually use an LLM to help me through this task, and let's talk a little bit about how. Right? So the user is going to ask a question like this, right? Who are the top 3 customers by total purchase amount? And the answer that we're expecting is going to be something like this. I want the LLM to be able to say the top 3 customers by purchase amount are person A, person B, and person C. Now, obviously, I'm not going to be able to write a prompt, no matter how good of a prompt engineer I am, for my model to actually be able to get out this information for a couple of reasons. My data is not even sitting with the LLM. My model has to be accessed through a SQL server. So it's a relatively complex task, but we can break this down in such a way that we can still rely on the LLM to actually solve this issue. Right? Let's take a look at an example of how. So at the very base, I'm going to give instructions to my model. I'm going to say you're an agent designed to interact with Azure SQL database. You have access to these tools for interacting with the database, blah, blah, blah. So when a user asks a question, right, what are top 3 customers by purchase amount? Now, here's a step-by-step that what's actually happened, okay? I am actually going to pull out all the tables that I have within the SQL server. Now, once I have that, I can see, oh, look, here are all the tables that I have. Now I'm going to give the names of these tables and maybe any descriptions that you have of these tables to the LLM together with the user question. And I'm going to ask the LLM the question, a very simple question. Which tables do you think will be useful in answering this question? Now the LLM will read the descriptions of the table, the names of the tables, and say, I should probably look at the schema of customer and invoice tables, right? Because I need to know the customer and I need to know the purchase amount. So it has made that decision. I'm going to look at a customer. I'm going to look at invoice. Therefore, look at these 2 tables accordingly. Great. I've done step 1. Now, the next thing I need to do is, okay, exactly what is the query that I need to execute on this table in order for me to get this information accordingly. So the next thing that we do is, now that I have those tables, I'm going to run another, I'm going to pull out all the fields that I have available in this table, and I'm going to feed this into the LLM. Now, I'm going to tell the LLM, here's all the information that we have in these 2 tables, and here's the user question. What is the SQL query that you should write and execute in order for you to answer this question? Now, LLMs, I'm sure most of you would know by now, are actually also great at writing code. And by extension, it will be able to write a decent SQL query for us. I've given you the schema of the table. I've given you the question that you're looking for. Now go ahead and form the SQL query accordingly, right? So you can see here, this is going to be the LLM's output. I can use the customer ID and total columns from the invoice table to get the total purchase amount for each customer. And here's the action, right? And this is the SQL query that I want you to execute. Select top 3, customer table first name, blah, 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 inner join with this, order by this, right? So once we have this, okay, now I have this SQL query. I'm going to actually execute this SQL query. And when I've executed the SQL query, what I have is going to be, well, this is what I'm going to get, right? I have the first name, the last name, and of course, the sales amount of these customers. I mean, we're not done here, right? I still need to respond to the end user. So I'm going to take this observation, which is the output of the query. I'm now going to send this output to the LM again. And I'm going to say, look, look at this observation over here and look at the user's query. Can you answer the question? Well, the top 3 customers by total purchase amount are Eleanor, Richard, and Louis, right? And so because of that, it's a relatively difficult task, but because we've broken this down into much simpler tasks that we know the LLM can execute with a high degree of accuracy, suddenly we are able to do something like this. Now, think about it from the user's perspective, right? Now, the user doesn't necessarily go in and type all of these things out. As the app developer, you would be the one that's building all these logic behind the scenes. So when the user actually asks a single question, who are the top 3 customers by total purchase amount, it will actually execute this entire workflow over here, right? Pull all the information required, execute the SQL query accordingly. And then the LM does a final step, compose the answer into a format that the user is expecting, right? Top 3 customers by purchase amount, blah, 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 and then return that to the user. So the user's experience is I ask a question, I get the answer, almost as if it's by magic. But now we know behind the scenes, there's a whole bunch of different things that's actually gone along the way in order for us to execute a query like this. Okay. Now, it's not just for chatbots, right? So you saw previously, we've always seen a lot, because of ChatGPT, we're very used to using LLMs to execute things like chatbots and so on and so forth. But there's a lot of different things that we can do as well, right? Building these LLMs into backend processors, building these LLMs as a natural language interface to complex legacy APIs that we might have, or even just using these to run backend workflows that used to be very difficult. For example, the parsing and the processing and the reply of emails or help desk tickets and so on and so forth. Not that it was impossible before, just that it was really manual, right? And something that we can really automate. Okay, so let's talk a little bit about functions. You saw a little bit of that with the example of me actually running and executing these SQL queries. Now, inside an application that you build, there may be a lot of different activities that it may be able to do, right? For example, if let's say we'll talk about that last example with SQL, I've actually given my application the ability to look up tables, to look up the schema of the tables, and I've also given it the ability to run the SQL query itself. Now the question is, when should it do what? When should it call tables? When should it call schema? When should it actually execute the SQL query? That's a decision that we would typically say, oh, that's where the human comes in, or we can hard code it into a workflow. But the idea here is now, since the LLM does have a certain level of a problem-solving capability, can we actually use this LLM to decide when and where and how I should be calling the function? Obviously, the answer is yes. That's why we're talking about it here. What I want to do is to actually get the model to suggest the function and the arguments to be executed, and then send it over to your application for the execution to happen. So, for example, your user will say, "Hey, when will my order arrive?" Your LLM, in this case GPT-3 or GPT-4, will read the question, understand the functions that you have available, suggest that you should probably execute this function, right? Suggest the function that needs to be executed. Your application will pick it up, execute the function with the parameters accordingly. So in this case, I'm going to query the API, query the database, call my APIs, get the results back, combine the answers, write the response accordingly, or at least consolidate all the information from the SQL query and the API call, send it back to the model itself, combine that together with the user's question, and then answer accordingly. Your t-shirt is expected to arrive on 10/25, right? Because it has actually spoken and executed a whole bunch of things behind the scenes. And again, because users are dynamic, right? We want GPT to be dynamic. So you don't really want to hard code this process, because then your user may end up getting really, really frustrated. Let's look at a very solid example, and I'm going to show you a couple of demos immediately after this. So we want to talk about, so the first thing you want to do, of course, is always to define the persona and how the behavior of your assistant in this case. Okay, so the example that we're using here is, your airline customer service agent, right? So you go in there, and rather than you actually going to do the booking or retrieving a booking, you want to be able to talk to a bot, or you want your users to be able to talk to a bot to get all this information itself. First things first, again, this whole idea is of prompt engineering. How do I write proper set of instructions, follow the 6 tips that we talked about previously, in order for me to really program my assistant to behave the way that I want it to do? I will say things like answer only with facts from the search tool. I will say things like, you are currently serving, and dynamically inserting the customer's name and the ID. We're going to talk about, what is this information that you need to look up, what you need to confirm, and so on and so forth, right? So this is basic stuff, right? I'm telling the bot how you should be behaving. The next thing I need to do is to actually go ahead and define what are the functions that you actually have available to you. Now, this looks like code, but if you look closely, it's not really, right? So it's a JSON format. But the way that I'm actually describing this function is actually in pure, simple English, right? The name of this function is search knowledge base. What does it do? It searches the knowledge base for an answer to the question. Okay, sure, that's what the function does. But what information do you need in order to search the knowledge base, right? I have a query that I need to use to search the knowledge base, right? So then the search query must be included, right? And I'm going to say that the search query must be required. So the user is asking, and sounds like I need to do a knowledge base search, but I don't actually have this required information over here. I'm going to face a couple of issues, right? And then of course the execution gets done. Last slide before we get into the demos themselves. So if let's say when you try to execute this function, now what happens is the LLM, in this case GPT-4, let's say, is going to check whether the model wants to use a function or not, right? So if you're going to say something like write me a joke, then okay, I don't need to call the function. But if I'm going to say, search through what are the flights available, then okay, I probably need to use my search knowledge base function. So it decides the function that it needs to use. It will get the function name, and then it will identify the parameters from the user's query. So user might ask something like, what is the next flight to Argentina from Singapore, for example, right? So then I'm going to have the parameters, which is flight from Singapore to Argentina on current date. Once I have this information, we're going to execute the function. You execute the function by calling your bookings API, for example. You're going to get this information back. Next flight is going to be tonight at 11 p.m. We're going to send this information back to the LLM. As a way, then the LLM is going to take this output, combine it together with the user's question, and then it's going to generate a response. And it's going to come out natural language that says something like, well, the next available flight that's available for you to book is going to be at 11 p.m. tonight on this particular flight at this time, landing from this airport to that airport, Okay, so let's take a look at a couple of these things in action, and also very importantly, how we're actually going to be able to build this ourselves. Okay, so I'm going to show you an example just starting previously when we talk about this whole idea of chain of thought, right? Or at least chain prompting, right? Doing a couple of prompts at the same time. So it's a really silly example, just hoping to give you an idea of what we can do. So I have written a prompt over here, and my first LLM here is just very simple. You're a bot that can tell good jokes. So what the user will do, the user is going to give you an input that says like car insurance, for example. Okay, and what the LLM is going to do is to tell a joke about car insurance. That's fine, but now we're going to change things up a little bit. Okay, what I've actually done over here is you can see I've built an entire workflow. Now, once a joke has actually been written, I'm actually going to ask again the LLM to rewrite the joke. Now, this time, they're going to have a couple of rules that I want you to follow. All right. So here I've actually gone ahead to provide the rules that says, tell me a joke tell the joke using an iambic pentameter. And of course, if the joke is offensive, give me some kind of witty reply, declining to answer instead, right, of, retelling an offensive joke. Now, what does the second, so those are the rules that I have. Now, what I have here, you can see this is a very dynamic prompt, right? So you're a joke writing assistant. Your joke is to rewrite the same joke, but follow the rules that you've been given. Make sure the joke has the same punchline and the same setup, right? And then you got to follow the rules here. So the rules can be dynamic. I might even decide that I'm going to let my users decide what rules they want to have to follow. Maybe something like, do not use the letter E or something like that, right? So they'll be given a joke as an input, and then of course it's going to rewrite the joke. So what does that kind of look like? I've actually already ran this previously, so we can take a look. Now, if I'm going to say write a joke about car insurance, right? So this is the joke that is written. Why did the car get an award? Because it had outstanding coverage and didn't need to worry about its day job as an SUV, as a superstar. Whether or not it's funny, I'll leave that to you to decide. All right. So that's the joke. Now, what I've said is that go ahead and rewrite this, using an iambic pentameter. So what's going to happen is that it's actually going to execute, and this is the response that we get, right? Why did the car take home the prize, you think, for its coverage grand and in its class unique? Okay. Well, that's written in the iambic pentameter. Whether that's true or not, well, we should probably go ahead and verify that, right? But you get the point. So a user can come in with any kind of input, just as car insurance or the ocean, the sky, or whatever. It's going to write a joke. Now, once the joke is rewritten, I'm not going to stop there. I'm going to force you to actually rewrite it again using an iambic pentameter. And then that's actually going to be the output that the user sees, which means that this joke here, that if first written, the user will never actually we'll never actually see. So let's take a look at some of the outputs that we have. Right? I've actually ran this in a batch. So I've given a whole bunch of different topics. You can take a look at what that might look like, right? So I said, well, here are 5 different topics: so car insurance, kayaking, food, webinars, artificial intelligence, and motion, right? Just random topics that popped up in my head. This is the first joke that is written, and then of course we've forced it to rewrite it accordingly. Now we can of course make the rules dynamic, but that's depending on your application accordingly. But the point here being, again, user comes in asking something. You can actually ask the LLM to execute multiple different steps before the user actually even sees a response accordingly. All right. So keep this idea in mind, and we're going to move on to actually writing the functions themselves. Now, this example here may be slightly more complicated, but nothing too crazy, I promise you. Let's take a look at what's actually happening. Now, again, just remember here, I'm writing an application, which means that, the first thing that I need to do is to, define how my application works and what are these APIs that my LLM needs to call. So I need to build the APIs here. So I've actually built in just a couple of relatively simple ones. The first one is actually a web search, right? So I'm actually going to use the Bing Search API here. So, well, this is a function that, whatever I execute is just going to search Bing and going to give me a whole set of results accordingly. Okay. The next one here is a dummy weather API. So if you're reading this code, you can see that it's hard-coded. It's not meant to be a real weather API. Basically, if somebody asks for Tokyo, I'm going to tell you that it's 10, right? If you tell me what's the weather in San Francisco, I'm going to tell you it's 72. So that's what this API does. It's just supposed to simulate some kind of real-time weather API that you have. Okay, so these are 2 functions that I have available for my assistant to actually use. Okay, and this is standard. This has nothing to do with an LLM. This is just any other API or any other function that you might define in any app that you have seen so far. Okay, now what we're going to do here is we're going to write a couple of, I'm going to write the tools. I'm going to describe the tool that's actually available to you, right? So I have a couple of descriptions here. I'm going to say things like, what's the here is the weather function, right? So you can get the current weather in a given location. What is the information that I need? You need to know the location or the city and the state that the user is asking for, and need to know the unit, right? Because I can give it to you in Celsius or I can give it to you in Fahrenheit. Now I can say that location is required, but unit is not required. Okay, so this is me defining the function for the LLM. And again, here, this is a Bing search, right? So what this thing does is to search Bing to get up-to-date information from the web. And then what the information that we need is, of course, a search query itself. Okay, so I've defined the function over here. And effectively, I'm not going to go through all of this, right? It's going to be a little bit too long if, let's say, we're going to go through all of this. But effectively, what I've done is to say, look, you're going to get a user query, and you are going to decide based on the user query itself, both based on those 2 tools that you have, weather and the API and the Bing search. Should you do a Bing search, or should you use a weather tool, or should you just straight away answer the question accordingly? All right, so we're going to execute these functions. I'm just going to run this again so you can see how this thing kind of works. I'm going to ask where and when is the next Olympic Games. There's a couple of things you can see here that I've identified that, okay, I should probably search Bing. Now that I know that I'm going to be searching Bing, what is the query that I'm going to be searching? So we're going to search Bing for what is the next Olympic Games location and date. And the assistant's response is, well, next Olympic Games location will be Paris, France in July 26, August 11, 2024. Right? The reason why I did this is because this is live, because otherwise you're going to get an answer like, sorry, I'm an AI assistant model, blah, 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 and I'm locked into 2023, and all this kind of information. So because I wanted to have up-to-date live information, I'm going to attach and give it the skill to actually be able to call Bing Chat to augment its knowledge, so to speak. Now, instead, if I'm going to ask a different question, right, what's the temperature in Tokyo in Celsius? It will correctly identify that I should probably be getting the current weather, right? And I've also identified, based on the information that you have actually provided, that you're looking for Tokyo, and you want the unit in Celsius. So I'm going to respond to you that the current temperature in Tokyo is 10 degrees Celsius. All right. So just an example of what the kind of things you can build. There are many different tools in which they can be built in, many different kinds of skill sets that you can actually build in and get the LM to do. And the fundamental difference over here is that we've seen a lot of different chatbots across time. All right. The big game changer that we are seeing over here is now we're going to let the LLM decide what is this action that we want it to do. So we're going to move away from a simple LLM that just identifies information, regurgitates information, rewrites an email, to actually being able to to actually do actions, pull information as required, pull information from the right sources, and even execute functions accordingly. right? Maybe rather than me stopping here and saying what the temperature is, maybe I can actually push the current live information over into some kind of live dashboard that somebody else is monitoring, as for example. Okay. So in the interest of time, right? So I think that's going to be the topics that I'm hoping to cover today, right? So what I'm going to do now is I'm just going to move on into a Q&A portion, right? We're going to move on to the Q&A portion where I'm going to see if there are any questions that anybody has in the chat, right? So if you have any questions that you have that you hope to answer now, just quickly put in the chat and then we can hopefully get to your question as soon as we can. Okay, so first question that I have over here is, how do I iteratively edit a complex JSON instance based on a JSON schema? Sorry, let me just read this a little bit, right? So I have model entities, name customer, okay. Hopefully I'm able to answer your understand your question. Hopefully I'm understanding your questions a little bit. I'm interpreting your question accurately. So if we say that we have a complex JSON, right? And what I want to do is to be able to kind of maybe simplify that or extract information across multiple different calls, right? So hopefully I think that's what you mean, right? In that case, I think it really depends on whether or not the initial JSON input that you have is whether or not this is a fixed structure that you're working with, right? So if let's say we are dealing with a dynamic JSON structure, right? So that means the JSON inputs that you might be getting is going to be very, 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 very varied, right? Then it is going to be a lot more challenging. So I'm going to tackle that later. Let's talk about the simpler case, right? If let's say you are understanding very obviously where and when and how your JSON input format is going to be like. Now you've got a couple options here, right? Using maybe say a few short example, you might actually be able to, in a single pass, actually extract all this information that you need from your complex JSON just by giving your LLM an example of how to extract this information and where it should be. So if we say that we need to very specifically extract a particular model, if you need to extract any particular entities, for example, if we were going to give it a past example of what this JSON would look like and the correct answer that we're looking for that we are looking for, then that's going to be something that it will be able to do quite well. Now let's tackle the more complicated one. What happens if my JSON format is actually quite complex? Now, there are a few ways in which you can do it, right? So usually what we will do is we'll just try to let the LM extract information and maybe simplify it in a single pass, right? And you can probably do this as simple as just writing a very simple instruction of exactly what you want it to do, right? Based on this JSON format actually contains information regarding A, B, C, and D. I want you to be able to extract those information accordingly. Now, in the first pass, what will happen is that it will try its best, it may extract this information accordingly. Now, what we will typically then decide to do after that is actually run an evaluation step, right? Sort of like a double check step. Whether or not this is a good idea really is going to depend on exactly what you're using this JSON for. If we are talking about kind of back-end processing, that is not much of an issue. If we're talking about live processing, then you must consider that you're going to get a little bit of a latency issue. You may run into a bit of a latency issue there. But typically, then what will happen is once we get that information that has been extracted, we're going to run a second pass. And in my second pass, we're going to ask you to check this information, right? So one of the things that the LLMs are actually really good at is actually evaluation itself. So I'm going to give you the original JSON format that I have. Here's the answer that the model has actually extracted. Do a double pass. Can you double check against the answer against the JSON? Is this the answer that you were expecting? Right, and typically through a double pass, we will be able to get the answer accordingly, regardless of how complex the JSON is. If it's about kind of like reformatting a complex JSON into a simpler structure, then it's actually as simple as us really just defining what is the simple JSON structure that we want it to follow, and it typically does a relatively good job out of that. Okay, so hopefully I was able to answer the question. Apologies if I kind of misinterpreted it. And I think that's it. So it's a relatively quiet session. I think that was the only question I have. So Suze, if there's anything else you would like to add.
Hello, thanks so much, Zixuan. That was really a good session. Like, I love your passion for this topic, and I also love how you summarize the prompt engineering tips and examples. I noticed the Singlish there too, and you do have something for cats, right?
Oh, for sure.
Yeah, it was really cute. I've always been doing the zero shot or zero example prompts. So one question from me though, let me just put that in the screen so it's more obvious. Like, what is one way to test if our prompts are good or not?
Okay, so that's a very good question. If you think about it, if let's say I were to go through 6 different tips in there, there will be many different ways in which I can actually write a single prompt. Thousands of ways and almost infinite number of ways in which I can write a prompt. Similar to the way that we test code, we also want to set up a process in which we are able to test our prompts so that we can decide prompt A or prompt B, which one is actually better. And also a way for us to really decide whether or not, a prompt is good or not. So I do have a flow here that I'm going to flash on the screen. It's actually what we call an evaluation flow, right? So one of the things that we can do is to actually set a workflow up like this that actually allows my model to evaluate the output uh, of what you are expecting, right? So you may have, for example, a question answer pair, a question that you are asking with say 0 shot, and you have an answer that you are expecting. Now I may be able to actually put these as inputs accordingly and ask the LLM to go and compare what was actually generated by the LLM compared to my model answer. How different are they? And from a scale of 1 to 10, for example, how different are they? I'm going to give you an example here, again, using that joke example that I did previously. Now, I am writing a joke. I have a set of rules that I have set up for you. Now, I want you to actually evaluate how well the rewriting has gone. First of all, comparing the original joke to the rewritten joke, did you do a good job of preserving the meaning of the joke? Second of all, have you actually followed the rules accordingly? So that if you did follow the rules, you can see here, I'm going to say it's as simple as for every rule that you follow, give you a point. If you actually preserve the meaning of the joke, I'm going to give you an additional point. And if you miss it, then well, you get 0 points, right? So then actually this actually brings a very qualitative answer. Well, what is a good response? Is a response good or not? Into something that's actually quantitative, so that I'm actually able to put a number to it. This first prompt that I gave, which was 0 shot, is actually going to give me, say, an average 7 points, for example. And in the other case, when I've actually done multi-shot or 1 shot example, I'm actually going to increase my average response points to maybe 8 or 9, right? And that gives you an idea that, Spot is a much more reliable, maybe, for me to actually rely on a single shot and a multi-shot versus a 0 shot prompt. So hopefully that kind of answers the question.
Yep, it does. And I wanted to let you know, like, while we were talking about this question, more questions came in, but I'm also very mindful of time. So I'm just going to quickly float a few questions up and we see if we can address them. If it requires longer explanation, we'll probably have to take this offline. So, okay, so we have this question from Vince. First of all, he thanks you for the great presentation, and he says that if, let's say, we're building a Gen AI app which is customer facing, how would you address the following concerns? So I'm just going to pull out his concern here. So number one, ensure that the LLM is generating accurate and reliable content. So what metric and threshold is considered acceptable, and how do you compare performance of different models and prompts? So okay, he has one more, so I'm just going to pull it out first, and then we see. Okay, then another question would be how to ensure any sensitive or personal information is not collected and stored. So what test do you recommend?
Okay, very good question. I'm going to try to answer these questions as quickly as possible as I can, just to make sure we stay on time. So first of all, how do we ensure that LLMs are generating accurate, reliable content? Very good question. So we've all heard of hallucinations. We know that models, if left to its own devices, could very well actually spit out a lot of misinformation. One of the things that we do to solve it is this concept of RAG, right? Retrieval Augmented Generation. So we don't let the LLM actually just answer the question accordingly. We always retrieve a source, a source of truth for the LLM to refer to and then answer the question. So we're not going to tell the LLM, tell me what the answer is. I'm going to tell the LLM, read the question, read the text, tell me what the answer is according to the text. So in that case, your LLM won't actually generate an answer from no basis. It will actually read the text, summarize the answer accordingly, and then give it to you. In those kind of cases, we almost really remove the chances of it actually spouting out misinformation. Now, there may be still a case where it misinterprets the text. That is still definitely a possibility that we cannot, discount, right? But it will definitely, reduce the amount of hallucination that you do. So that's the first and most important thing that we do. Second question that we have, right, is metric. What's the metric and threshold that is considered acceptable? Very good question. So this really depends on your use case itself. As an example, if let's say we're going to be talking about very say life and death type situations, right? Then almost in that case, no error is acceptable, zero error is acceptable, and in that case, you probably would make a decision that goes all the way to the point of saying, I'm not going to rely on an LLM to generate an answer. But if let's say we're in a case where, a couple slight mistakes here and there may not be the worst thing in the world, right? Then, your threshold on how much you are willing to accept may adjust accordingly. What kind of metrics that you want to do? I'm not sure whether I have time to show you over on this, but when we talk about evaluations, one of the things that we can do is to actually. So I can show you here. We have a whole bunch of like evaluation flow for different ways in which we can evaluate whether or not the accuracy in the metrics. It could be a question on, if let's say we're talking about Q&A, right? Well, did you answer the question, yes or no? How many, I'm going to ask 100 questions. Out of these 100 questions, how many of them were actually answered? How many of them did not refer to the text and actually generated answers from nonsense, right? So just by doing a very simple yes, no score, or you could decide to ask the LLM to assign a score from 0 to 5, 0 to 10, for you to decide whether or not your model is actually performing well or not. Right, so this, of course, we talk about custom metrics. Now, if you go online, you go take a look and read a couple of papers. There's a whole bunch of different metrics that actually people use to benchmark LLMs today that you may decide to use as your own benchmark internally. Unfortunately, the answer is that there's no one correct answer of what exactly is the metric to use, but it really depends on the use case. The good news there is that actually you do have the liberty and the flexibility to make a decision that best benefits yourself for your use case directly, right? And then I think this also kind of answers the question: how do you compare performance of different models and prompts? Well, so using this is prompt flow, by the way. So this is one of the tools that we have in Azure. You can see here that I can actually ask the exact same evaluation step, but I can ask it to go across to many different models, right? So if I have Mistral in here, or GPT-3, or Llama, or whatever other models that you decide to use, I can actually just set up the exact same evaluation step using the exact same generation step using different models, and then afterwards I can run my evaluation step that gives you this ability to kind of benchmark across multiple different models and decide which one works best for your use case.
Do you want to take this on as well? I mean, I'm mindful of time. Yeah.
Sure. Sorry. Yeah, I kind of missed it out. Right. So ensure sensitive personal information. So this is a very, very important step. Before you use any of these models, make sure that you are aware of the data privacy policies. Make sure that none, if they are using sensitive information, make sure that there's an agreement in place that none of this data will be used. What I can tell you is that for Azure OpenAI, so if you're using OpenAI models through Azure, none of your data is stored, none of your data is being used. So you don't have to worry about your information suddenly popping up in GPT-5 or showing up in GPT-5. So that's not going to happen if you use OpenAI on Azure. So that's a guarantee that I can give you. We can talk about, of course, about privacy policies on Azure. That's probably not something I'm going to go through into a lot of detail here. But if you're using your LLMs and your models on Azure, rest assured none of them is stored and none of them is going to be used.
Right. Okay. So we have two more questions, and I'm also very mindful of everybody else's time. So I'm gonna stop taking questions at this point, but maybe we can close off these two, and then Zishan, you let me know whether that works for you. Okay. So we have this question from Daniel. He said that if we are dealing with complex database with different fields, which not always all relevant, how can we identify correct documents to extract content from? Is there any algorithm to help that? Yeah.
How can we identify correct documents to extract content from? I'm going to make a couple of assumptions on the kind of database that you are dealing with. So my understanding is that you're asking for, say, database, say like a SQL database, but then later on you said talk about documents. So I'm not sure whether or not you're talking about document database or we're talking about tabular databases. For tabular databases, the important part is being able to have the metadata and imagine a data dictionary describing exactly what these fields are and what they represent, giving this information to the LLM so that it can decide which fields it needs to pull the information from. This part is super key, especially if you have fields that are named and tables that are named very, very similar, right? So that's the important part. If we're talking about document databases, well, that's where this whole concept of RAG comes from, right? So the retrieval step is also a very complex step There are many different ways and tools that you can use to make ensure that you have a good retrieval. One of the ways, for example, Microsoft, we have AI search that has its own search algorithm that helps you rank relevant documents based on your search query. Alternatively, you have the more popular method right now, of course, which is this idea of embeddings, right? So we generate embeddings based on your text using models like OpenAI models, for example, to generate embeddings, store them in vector databases, and then we kind of like do that matching. So we basically use these kind of like LLMs, not really LLMs, these embedding models, specifically embedding models that actually helps us to do a match between whatever the user is asking together with the document finding that helps us actually identify the right documents, right? So those are the algorithms that we use, to answer these questions. So hopefully I got that. Hopefully I got your question correctly.
Okay, we'll move on to the last one. Okay, so it's from Stefan. Like, what's the best to restrict a response to only use specific sources? So, for example, if it has access to a SQL database, ensure that it will not answer questions which don't use that source.
Very good question. First of all, if you're in a situation where your model or your application should never be using a particular source, then I would say that don't give the model access to that source in the first place, right? So if it doesn't have permission to access those tables, then it cannot access those tables. That is the most secure and the best way for us to do it. Barring that, another way for you to do it, of course, is to actually kind of write those instructions into your prompt. So you are a SQL agent that helps people do this, and you retrieve and blah blah blah. In any case, and this is where we would write. This is where the prompt engineering comes in. So part of it is also us giving explicit instructions to say, regardless of the question that the user is asking, do not, you should never be using this particular table, or you should never be querying across this table. Disregard any question that is asking questions that require me to access these particular tables. Right? So that's one way of doing it. But that will never be a recommended way. The most recommended way for us, we will always tell you, well, least, the principle of least privileges, right? Don't even give the model or your application access to the table in the first place. Then you can be 100% sure that data will never leak to the user.
Right. Okay, perfect. Thank you so much. I think the questions were very engaging. Let me just remove this one. And it's really nice to see so many questions coming through. So if you're watching this and you found today's session super helpful, please take the time to hit on the like and subscribe button, or maybe hit on the notify button so you'll be notified of such content. Again, because we see so many of these questions coming through, right? Let us know if you like a AMA session with like maybe Zishan or similar topic. Like we'll make sure that to arrange one. And so you probably know our mission. Sorry, Zishan, can you go back to like the slide before? Yeah, thank you. Yeah, so you probably know that our mission at Microsoft is to empower every human and organization to achieve more. So this includes startups as well. So we want to enable founders to be able to solve world problems and build a better future. So if you have plans to create a product centering around AI or accelerate your AI innovation, we just wanted to share that there's this Microsoft for Startups Founders Hub. It's basically a dynamic platform and ecosystem supporting founders like you from ideate stage to development, grow, and scale stages. So we're talking about free OpenAI credits up to 150K, Azure credits, and you have access to heaps of development tools and even third-party tools like Sales Navigator, Recruiter, blah, blah. So there's a huge chunk for you. So lots of good stuff, and I encourage you to check that out. I'm just also going to drop it here in the ticker so you can click on it. So if you have enjoyed today's session, please join us for the next one. It's basically a few more sessions that we have in February. It's to be delivered in Tagalog as well. So if you're multilingual, I think that would be super helpful. So finally, we have also included a survey to today's session. If you have time, please help us fill that out. We'll greatly appreciate that. You can do so on the Reactor YouTube channel straight after today's live stream. You can watch that. So this survey is really important for us to know how we are doing and if we should be doing similar content again. Let us know if you'd like us to be back. So we kind of like overstretch a little today. And last but not least, you will see this in the YouTube description. I just wanted to call this out. There are more resources available. You can actually click on this link to find out more and to learn more after today. So Zishan, do you have anything else to add before we close this session?
No, I think that's about it. Thanks everyone again for your time. Hopefully this was an informative session for everyone. and always keep coming up with new use cases. I think one thing that has amazed all of us here at Microsoft as well is the ingenuity of the use cases that a lot of our users actually come up with when it regards to generative AI.
Okay, great. Thank you so much for joining us today. We look forward to seeing you in our next few sessions. Thank you.